Smart contracts are self-executing contracts that run on a blockchain platform. They contain the terms of an agreement between two or more parties, written directly into lines of code. These contracts are designed to automatically execute and enforce the terms of the agreement without the need for intermediaries like banks or legal institutions. The concept of smart contracts was first proposed by computer scientist Nick Szabo in 1994, but it wasn't until the development of blockchain technology, specifically Ethereum, that the concept became a reality. The immutability and decentralized nature of blockchain technology provide the perfect environment for smart contracts to function securely and transparently. There are numerous use cases and benefits of smart contracts. They can streamline complex processes, reduce the risk of fraud, increase efficiency, and reduce costs associated with traditional contract management. Some common applications include supply chain management, voting systems, insurance policies, and decentralized finance. Despite their potential, smart contracts also face several limitations and challenges. One of the primary concerns is the issue of coding errors and vulnerabilities, which can lead to security breaches and loss of funds. Additionally, the legal status of smart contracts remains unclear in many jurisdictions, and their enforcement may not always be recognized by courts. Finally, scalability and transaction costs can pose challenges, particularly on congested blockchain networks like Ethereum. Ethereum, often referred to as the world computer, is a decentralized, open-source blockchain platform that enables developers to build and deploy smart contracts and decentralized applications, DApps. Launched in 2015 by a group of developers led by Vitalik Buterin, Ethereum has become the most popular platform for smart contract development, driving significant innovation in the blockchain space. Ethereum played a pivotal role in the development of smart contracts by introducing the Ethereum Virtual Machine, EVM. The EVM is a decentralized computer that can execute code written in a Turing-complete language called Solidity. This allows for the creation of complex smart contracts that can perform various tasks and interact with other contracts on the Ethereum network. There are several key components within the Ethereum ecosystem, including Ether, ETH, and Gas. Ether is the native cryptocurrency of Ethereum, used to power transactions and smart contract execution. Gas, on the other hand, is a unit of measurement that represents the computational effort required to execute a transaction or smart contract. Gas fees are paid in Ether and are used to compensate miners for processing and validating transactions on the network. Decentralized applications, or DApps, are another important aspect of the Ethereum ecosystem. These applications run on top of the Ethereum blockchain, leveraging smart contracts to enable decentralized and trustless interactions between users, without the need for intermediaries. Ethereum 2.0, also known as ETH2 or Serenity, is a major upgrade to the Ethereum network aimed at improving its scalability, security, and sustainability. The upgrade will introduce significant changes, such as the transition from a proof-of-work (POW) consensus mechanism to a proof-of-stake (POS) mechanism, which will allow for a more energy-efficient and scalable network. Ethereum 2.0 is being rolled out in multiple phases, with the final phase expected to be completed in the coming years. Solidity is the programming language specifically designed for writing smart contracts on the Ethereum blockchain. Created by Ethereum co-founder Gavin Wood, Solidity is a statically typed, contract-oriented language that draws inspiration from languages such as JavaScript, Python, and C++. Its purpose is to enable developers to create, deploy, and interact with smart contracts on the Ethereum network. The syntax of Solidity is designed to be easily understandable by developers familiar with other programming languages. It offers various key features, including functions, variables, control structures, and error handling. Solidity also provides support for inheritance, allowing for the creation of complex smart contracts using a modular approach. To provide a basic example of a Solidity smart contract, let's consider a simple contract for a decentralized voting system. The contract would include variables to store the list of candidates, a mapping to track the number of votes each candidate receives, and functions to add candidates, cast votes, and determine the winner. When it comes to learning and mastering Solidity, there are several tips to keep in mind. First, familiarize yourself with the language's syntax and features by reading the official documentation and following tutorials. Next, practice writing simple smart contracts and gradually move on to more complex examples. Finally, engage with the Ethereum development community by participating in forums, attending workshops, and seeking out mentorship from experienced Solidity developers. By understanding Solidity and its core concepts, you'll be well equipped to create, deploy, and interact with smart contracts on the Ethereum blockchain, unlocking the full potential of this powerful technology. To successfully create, deploy, and interact with smart contracts on the Ethereum network, you'll need to utilize a variety of tools and platforms designed specifically for smart contract development. First, you'll need a development environment to write and test your smart contracts. Remix is a popular web-based integrated development environment, IDE, that allows you to write, compile, and test Solidity code directly from your browser. For more advanced developers, the Truffle Suite offers a robust set of tools for building, testing, and deploying smart contracts using a local development environment. Once you've developed and tested your smart contract, you'll need to deploy it onto the Ethereum network. MetaMask is a widely used browser extension that functions as an Ethereum wallet and allows you to interact with the Ethereum blockchain. With MetaMask, you can deploy your smart contract by connecting to the Ethereum network, selecting the appropriate contract, and sending a transaction containing the compiled contract code and necessary Ether to cover the deployment costs. Gas. After deploying your smart contract, you'll need a way to interact with it. Decentralized applications, DApps, are web applications that use smart contracts as their back-end, providing a user-friendly interface for interacting with the Ethereum blockchain. To build a dApp, you'll need to use Web3.js, a JavaScript library that allows you to interact with Ethereum nodes and smart contracts directly from your web application. By utilizing these tools and platforms, you'll be well equipped to create, deploy, and interact with smart contracts on the Ethereum network, further expanding your understanding of this powerful technology and its applications in the world of blockchain. Smart contracts on Ethereum have given rise to numerous innovative applications that have transformed the way we interact with digital assets and services. Let's explore some of the most prominent real-world applications of smart contracts on Ethereum. A. Decentralized finance, DeFi, is a rapidly growing sector that uses smart contracts to create decentralized financial products and services, such as lending platforms, decentralized exchanges, and yield farming. DeFi allows users to access financial services without relying on traditional financial institutions, providing more inclusive and transparent financial systems. B. Non-fungible tokens, NFTs, are unique digital assets that can represent ownership of various items, such as art, collectibles, or virtual real estate. Smart contracts are used to create, transfer, and manage NFTs on the Ethereum network, enabling a new world of digital ownership and value exchange. C. Decentralized autonomous organizations, DAOs, are organizations that use smart contracts to automate decision-making processes and governance. By leveraging the power of Ethereum, DAOs can operate without central authorities, allowing for more democratic and decentralized decision-making structures. D. Smart contracts are also being used to revolutionize industries such as supply chain management and identity verification. For example, they can be used to track products throughout their life cycle, ensuring transparency and trust among various parties. Additionally, smart contracts can enable secure and verifiable digital identity solutions, streamlining online services and reducing the risk of fraud. These applications are just the tip of the iceberg when it comes to the potential uses of smart contracts on Ethereum. As the technology continues to evolve and mature, we can expect to see even more innovative and transformative solutions emerge in the world of blockchain. In conclusion, smart contracts have emerged as a revolutionary technology in the blockchain and cryptocurrency space. They enable the automation of contractual agreements, ensuring trust, transparency, and efficiency in various industries and use cases. As decentralized and self-executing agreements, smart contracts minimize the need for intermediaries and reduce the potential for human error or manipulation. However, it is essential to acknowledge that smart contracts are still a relatively new technology, and there may be challenges, such as security vulnerabilities, scalability issues, and legal concerns, that need to be addressed as they continue to evolve. By staying informed about the latest developments and advancements in smart contract technology, users can harness their full potential while mitigating associated risks. Overall, smart contracts hold immense promise for transforming the way we conduct transactions and agreements in a decentralized and digital world.